Okay, welcome back and welcome to week 7. Ooh, 7 out of 16. We're getting there, aren't we? Okay, this is about chapter 5 and chapter 6 in the big book. So, chapter 5 is about the file system. Starts on page 120. And just as a reminder, the way Linux Unix works is that everything is considered a file. You know, a disk is considered a file, a keyboard is considered a file, a mouse is considered a file. Everything is a file. And so the way it works is you mount, and you've seen us do that a couple of times, where we mount devices on, we just graft them onto the tree wherever we want them to be. I want a floppy disk to appear here. I'd like a CD-ROM to appear here. I'd like another hard drive to appear here. And you just pick the locations where you want them and you mount them in the tree. Okay, cool. So, devices are mounted to the file system, and there's an entire procedure you have to go through, which we're going to demo here. Okay, so what's the purpose of all this file system stuff? Well, obviously it's to present and organize storage. I mean, that's what it's all about. You know, we have lots of storage resources out there. We have, USB flash drives and all the rest of that stuff, and you want to be able to mount them into the file system and do the thing. Okay, so when it comes to disk-based file systems, like a hard drive or a USB flash drive or something like that, even a CD-ROM, sort of, there's lots of choices. In the Windows world, they go by these really cool acronyms, FAT and FAT32 and exFAT and NTFS. Those are all Windows-based file systems, and they work fairly well for doing what they want to do. In our world, those actually, some of those are available, but that's not the norm. Normally, we use a thing called EXT. So EXT4 is typically what we use for the honest-to-God real files in the file system. And maybe the part of the file structure where we boot, the bootable parts, it could be a little lesser file system. It doesn't need to be quite so robust because there's hardly any writing going on to the boot sections of the file system, right? I mean, it's just maybe when you update the operating system, but it's not like daily operations take place there. So it could be what's called an EXT2. Okay, don't worry about what EXT stands for. It's just a naming convention they came up with these guys. So to see how and where each one of the devices are mounted and what file system they're using, we're going to use the df command. Now, we probably have used this before, but I'm going to say df minus t, and a capital T. And this is going to tell me the file system, what the file system type is. See where it says ext4? Because that's the root of our file system is ext4. Cool. Now, we have a couple others. We've got the VBox one, which is, kind of odd because, normal Linuxes wouldn't necessarily have that. Then we have a tempfs, and then we have a dev tempfs. But anyway, bottom line is, typically the parts that we're concerned with, where we're talking about a real hard drive being grafted onto the tree, it's probably going to be an ext4 file system. Okay. So let's talk a little bit more about what the heck a file system is. So the two major file systems that exist in the Linux world are these ext variants. Wait a minute now, let me rephrase that. There are a gazillion file systems out there. I mean a lot. There's ZFS and tons of all the rest of these types. But the two major ones are going to be the ext variants, and then one called network file system, NFS. So NFS is basically like on top of, that's kind of a weird way of looking at it. So you have the physical hard drive mounted as ext4. And then you have a network file system on top of that file system that allows other people from other machines to be able to get to your stuff. So it's actually 2 in 1, the real physical one, and then this upper layer one where the file system is being exposed through the network. Cool. Okay. All right. So that's essentially the nutshell of how file systems are kind of put together. We're going to do one in just a moment. Okay, on page 122, they start talking about path names. So, as you know, it's a hierarchical file system with everything starting at root, the slash. Directories, all directories fall underneath there. And we've done this before, but just let me rephrase this. So that means an absolute path because I'm starting with a slash, which means it has to go at the top and work itself down, right? And so if I did like this, that would be starting at the top, then going down. Cool, right? Makes sense. Or I could say this, which means go up, which, by the way, should be the same thing, right? Because going down to home and going up from my home directory should be the same thing, right? Yay, it is, hooray. And let's say I wanted to go up, and then go to dev. So I want to go up once, and then down once. Okay, so up, and over. I would do ls up, and then pick one. I'm going to use dev. Actually, I probably should use bin since it'll be shorter. Okay, cool. So up, and down. Cool. All right, so you got these little synonyms. You know what an absolute path is. You know how to do relative paths. You know the dot and the dot. Okay, good. There are some limits. Most file systems have a built-in set of limits, and the one we're using, the ext4, particularly has 256 character limit for each folder name or file name. Okay? With a combined means you add them all together, starting at root, slash whatever, of 4,096 characters. Now that is not universal. There are other file systems like ZFS, which you can have practically unlimited number of things. But to tell you the truth, it kind of makes sense to keep this kind of compatible, particularly since if you're trying to switch back and forth between the Windows world and the Linux world, you might have a bit of a trouble if you start exceeding one of their limitations. So 256 characters for any single directory or file, and then in combination, starting at root, it's starting at its mount point. It's 4,097 characters, or 96 characters. Sorry. Okay. So we're going to actually do one now. Are you guys ready? Okay, cool. So first thing we're going to do is I'm going to have to create a new fake hard drive that we're going to mount into our image. Cool beans? Okay, so the first thing we need to do is I need to go in here and add a disk. Now, most likely we're not going to be able to add a disk with the system up and running. Unfortunately, that's one of the few things that VirtualBox does not do well, is I can't add a new disk with the system up and running. So I'm going to go ahead and just shut this guy down. Okay, and then I'm going to bring this guy up. And we're going to go here, we're going to add a disk. So I'm going to go to settings. And I'm going to go to storage. Okay, so right now we have a SATA controller and we got this disk. So I want to make sure that I'm on the SATA controller and not the older IDE guy. So I just click, to let it know, this is the one I'm talking to. And then there's a little plus sign there. One of those says, hey, you want to add an optical drive? Not particularly. Would you like to add a hard drive? Yes, I would. Okay. So I'm going to hit create. I'm going to tell it that I want the default, and then dynamically, like we did last time. Where do you want to put this thing? And what do you want to call it? I want to call it something different than that. I'm going to call it public, just because later on we're going to mount this thing into a directory called public, so it just kind of makes sense that the name of the disk in VirtualBox means something to me when we get a little bit further. And and I don't need it to be quite so big, so I'm going to pick 4 gig because we're just kind of goofing off. Okay, so I'm going to say create this guy, and there we go. And so now it has put that guy onto my controller. Hooray! So now I have 2 hard drives on there. Excellent. So now that I have 2 hard drives, now by the way, that hard drive hasn't been partitioned or formatted or anything. So when we boot up Ubuntu, which we're getting ready to do right this very second, it's not going to see anything at all. I'm going to minimize this guy because we haven't told it about it. I mean, yes, when the system probes the devices, it's going to see that there's another device, but that's all. We're not going to get anywhere, which is kind of cool. Okay, so let me log in. Oh, come on. Really? Yeah, yes, 4335. I guess I should slow down a little bit. Yay, it likes it. Okay, cool. All right, so step 1 is going to be, I need a place to mount this. I'm grafting this thing onto the tree, right? I need some place to put it. So I'm going to go up to the root, and I'm going to create a folder called public. There is already one called public. And one of the naming conventions that I use, if I'm doing something different than the system was designed to do, like didn't come out of the box, I use capital letters. And that way I can instantly see, oh, wait, that's not a real one. That's, that's one that we did. So I'm going to do a make dir public. Okay, now is this going to work? No. It's going to come back and say, hey, man, you ain't got that right kind of permissions for that. Like, you're right. So I'm going to do a sudo make dir public. CIS4335 parents, close parents. Yay! Okay, let's make sure it's there. And cool. And I would imagine if I did an ls-al on public, it should be having absolutely nothing on it, in it, right? I mean, wouldn't you think that? Yeah, it's empty. Cool. Okay. Now we need to go find that device, and we need to partition it. Okay, so there are some steps you have to follow. So one of the steps is I need to create a mount point. We just did that. The next one, I have to partition the disk. So a single disk can have multiple file systems on it. That's not how we're going to do it. So, but the partitioning step is still required. Okay, so remember how we did DF and it showed all of the existing ones? Okay, well, ours is not on the list. All right, so you might think, well, wait a minute. How come ours is not on the list? Because it's not already mounted, like we just talked. So we need another one. We need one that does, there's a one called LS for list HW, okay, for list hardware, okay? And then it'll give you, boom, all this stuff. It also has a little thing there that says, oh, yeah, by the way, you might want to do this as root to be able to see everything. So what I'm going to do is I'm going to do this again, except this time I'm going to say sudo delete, and then I'm going to tell it, hey, I don't want to see everything, doggone it. I just want to see those things that are disks. So capital C disk. Okay. So if you look at this thing, go down here to all these things, you'll see that I have 2 of these VBox hard drives. See where it says VBox hard drive, hard disk? Yeah, that's the one we want. So there's like a naming convention for hard drives. So this one is the previous one is dev/SDA. And I think that stands for SATA disk, and they just start with the letter A, okay? So the second one at the bottom says dev SDB. So this is the second hard drive that they've added onto there. Now, when we look at you can look at a device and figure out the differences between a partition and a raw disk. In other words, am I talking about the device or a partition under the device? And that the way it works is they have partition numbers. So if I was talking to the first partition on SDA, it would be SDA1. Okay? We don't have any partition, so ours is just SDB. Okay, we're coming up on the 15-minute mark. You know what to do.